Hello everyone, we want to find the points on this parametric curve where the tangent is horizontal or vertical. To do this, we will need to find the derivative function dy over dx. And to find dy over dx, we actually need to find dy over dt and then dx over dt so that we can have the derivative function, because the dy over dx is actually coming from the dy over dt over dx over dt. So let's get started. So first, we are going to find the derivative so that we can see what's going on. And then dy over dx is actually equal to dy over dt over dx over dt. Okay. So now what we are going to do is that we need to take the derivative of y with respect to t, and that will become our numerator. And so what do we get when we take the derivative of this function here? We are going to get 2 cosine t and then minus 2 cosine of 2t. And then, yeah, so that's our numerator. And then for the denominator, we need to differentiate the x with respect to t. So we are going to get negative 2 sine of t and then plus 2 sine of 2t. So that's our dy over dx. Okay, we know that the tangent is horizontal when the derivative is equal to 0. And so that's really just when the slope of the tangent line is equal to 0. So that's why we need the derivative to be 0. And in order for this derivative to be 0, in order for this fraction to be equal to 0, we need to have the numerator is equal to the 0, but the denominator is not equal to 0. So what are we going to do here? We are going to set the numerator equal to 0, but at the same time, we also need to set the denominator equal to 0 so that we see if there is a solution that will actually cause the numerator and the denominator to be equal to 0 at the same time. Okay, so first we are going to set the numerator equal to 0 and then try to solve that equation for t and see what's going on. Okay, so we are going to have 2 cosine of t minus 2 cosine of 2t, and then that's equal to 0. And so what we are going to do is that we are going to first look at a formula. This is called a double angle formula, which is cosine of 2x. It's really because we have a cosine of 2x right here. So to solve this equation, we need to actually rewrite this in terms of a cosine function, because we have a cosine function here. We need to rewrite this cosine of 2t as a cosine function, but the argument will just t instead of 2t, so that we can solve the equation. So we are going to recall that the double angle formula is cosine of 2x is actually equal to 2 cosine square x minus 1. And in this case, the x is just the t, right? So we can actually substitute this cosine of 2t by this expression right here. So what we are going to do is that we have, oh, by the way, we can actually divide everything by 2 at the same time. So if we do that, then we can actually cross out the 2, as you can see here. So we are getting cosine of t minus, now we need to put parentheses because there is a minus sign in front of this cosine of 2t, and then we are substituting 2 terms in here. So we are having 2 cosine square of t minus 1, and then that's equal to 0. Okay, now we actually do not need the double angle formula anymore, so I'm going to erase it. And then let's focus on solving this equation. So what happens right now is that we are going to distribute this minus sign to both terms inside the parentheses so that we do not have parentheses anymore. So we have 2, negative 2 cosine square t, and then plus cosine of t, and then plus 1 is equal to 0. And because the leading term, this quadratic term in terms of cosine is having a negative leading coefficient, so we can actually multiply everything by -1 so that we can turn that coefficient into a positive coefficient. So if we do that, then we are going to get 2 cosine square t minus cosine of t minus 1 is equal to 0. So all the signs are changed, right? -2 becomes +2, positive becomes negative, positive becomes negative here. Okay. So now you can actually factor this expression, which will actually give you what we have. Let's look at the factorization right here. So we want two things that we multiply to get 2 cosine square t, which will give us 2 cosine t. And then there is another one is cosine t. And then we want two things that will multiply to -1. So we have one here and then one here. And then, so in order for us to get a negative cosine t here, we need to have 2 cosine t times 1 to be -2 cosine t. So we put a minus sign right here. And then the other sign would be +1. So that you have -2 cosine t times 1 cosine, plus 1 cosine t. That will give you the negative cosine t here. So now we can actually solve this equation because we factor this expression on the left hand side of the equation, and then we can set each factor equal to 0 to solve that equation. Okay, so what we're going to get is that we have this 2 cosine t plus 1 is equal to 0. So that's actually what? That's actually 2 cosine of t plus 1 is equal to 0. And that will actually give us cosine of t is equal to -1/2. Okay, so I believe that I need a little bit more space at the bottom. So I'm going to make this smaller so that I can get more space. Yeah, so now I get a lot more space. Okay, let's continue. So let's see what's going on here. We have this first case, which is 2 cosine t plus 1, and that's equal to 0. So this is equal to -1/2. When is cosine equal to -1/2? That's when you have a reference angle of pi/3. Okay. So the reference angle is what? Reference angle is so reference angle is going to be pi/3. And then the quadrants would actually be quadrant 2 and quadrant 3. That's when cosine is negative. And so the two angles that we have that will make cosine equal to -1/2, and those two angles must also be between 0 and 2 pi. Those two angles would actually be t equals, the one from quadrant 2 is 2 pi/3, and then the one from quadrant 3 is going to be 4 pi/3. Okay, so we have that. Now, what about the other case? What about the other case? The other case is going to be just cosine t minus 1 is equal to 0. And then that's really just saying that cosine t is equal to 1, right? You add the 1 to both sides of the equation. And then when is cosine t equal to 1? That's when you have a quadrantal angle. And that's when t is equal to what? That's when t is equal to 0 or 2 pi. Okay, so we actually will have those two solutions for this case right here. Okay, so that's that one. But then we also, as I mentioned before, we also need to set the denominator equal to 0 and then see what's going on, right? Because we want to see if there are any values that will also make the denominator equal to 0 at the same time. And then we need to do a little bit more work in that case. So what are we doing here? We are going to set this green expression right here. which is negative 2 sine of t plus 2 sine of 2t equal to 0. Okay, let's see what's going on here. As you can see here, there was a sine of 2t right here. We are going to recall another double angle formula. So let's just recall that one here. That's when you have sine of 2x, and that's equal to 2 sine x cosine x. Okay, so we can actually substitute this expression in here. So what are we doing here? We are going to write negative 2. Oh, by the way, we just like the previous case, we can actually cancel out the 2, right? We don't need the 2 anymore. And so we are going to get negative, no 2 anymore. So negative sine t, right? And then plus, this time we do not need to put the pair of parentheses anymore, right? Because that one was a minus sign, so I put a pair of parentheses right here, but this is a plus sign, so I can just copy. So I'm going to get what? I'm going to get 2 sine of t, right? The x is just the t here in this case. And then we are going to get the cosine t, and that's equal to 0. Okay, so now this one, even though we are getting two different types of functions in here, there was a sine, there was a cosine, but then we can factor out the sine, right? So if we factor out the sine function, then we are going to get what? We are going to get negative 1 plus 2 cosine t. That's equal to 0. And then we actually don't need this double angle formula anymore, so let's erase it. Okay, so we have a product now, so we can start solving the equation. One of the cases is sine t, right? That's must be equal to 0, so that's our first case. So sine of t. So sine of t is equal to 0. And then again, this would be a quadrantal angle. So that's when t is equal to 0 or t is equal to pi. Okay. Okay, next. The other case is when negative 1 plus 2 cosine t is equal to 0. So if we're solving for cosine t, then we are going to get 1 over 2 here. We're going to get 1 over 2. So in this case, we are going to look at the reference angle. For cosine t being 1 over 2, then the reference angle is just like before. It's going to be pi over 3. And then the quadrants, because this time cosine is positive, so we are going to get quadrant 1 and quadrant 4. And so now our angles would actually be, what is our angle right here? Our angle would actually be pi over 3 because that's in the first quadrant, and then the other one is in the fourth quadrant, which is 5 pi over 3. So now we get all those ones. There's one thing that I want to point out here is that there are t values that will actually make both the numerator and the denominator equal to 0. Oh, I forgot to mention that there was one more right here, which is t equals. That's when t equals. Do you know what that is? That's t equals 2 pi, right? Because I almost forgot about the endpoint right here. So as you can see right here, do you actually see what's happening right here? It's really this one and that one. And those are the two t values on this interval that will actually make both the numerator and the denominator equal to 0 at the same time. Okay, so and then you may say, then what happens? What's going on, right? We actually want to see whether that's a if you know the graph, then of course you can tell where what at those locations whether the tangent is horizontal or vertical. But in this case, we actually want to see what happens. What do we want to see here? We want to take the limit and see if what happens when we approach 0 and also when we approach 2 pi. Okay, so what we are going to do is that we are going to take the limit right now. And so let's do that. So what are we doing here? We take the limit as x approaching 0 from the right side because we are having all the values, all the t values greater than or equal to 0. So we are going to let x approach, no, not x, right? There was no x in the problem. So it's actually t. So if we are going to let t be approaching 0, oh, actually there was an x in here, but that's not the x that we are talking about. So make sure that you use the right variable here. That's a good lesson. Okay, so let t be approaching 0. Okay, of this function. So we are going to consider this dy over dx right here. And that's actually what? That's actually the limit problem as t approaching 0 from the right side. And then we are having this expression right here. This is our derivative function. So I'm just going to copy that over here. So it's that one. And then you may say, what's going on right here? If you plug in the 0, you know that based on our solving of the two equations, we know that the top is approaching 0 and the bottom is approaching 0, right? So now, because that's an indeterminate form, so we can use L'Hopital's rule to help us find the answer for this, which will give us what? Which will give us, if we are to take the derivative, then what do we get here? So we are going to get what? We are going to get negative sine of t, and then we are going to have plus, okay, and then, oh, by the way, you may say, why do I give her the 2? Because they all the terms have a coefficient of 2, right? So we can actually cancel them all before we take the derivative, which will make things simpler. And we are actually going to be getting cosine of 2t, right? No, actually we are going to be getting 2 sine of 2t. And then in the denominator, we are going to get something similar, which is negative cosine t. And then we are going to get plus 2 cosine of 2t. And so if you actually now plug in the 0, then you are going to get 0 at the top, but then the bottom is not going to be 0. It turns out that the bottom is just what? Just 1, right? Just 1. Because you're going to get a 2 here, you're going to get a negative 1 here. 2 minus 1 is 1. So we actually know the answer is simply just 0. Okay, now what happens when we take the limit as t? Yeah, so I don't know why I kept writing x. When we're approaching 2 pi from the left side, what are we going to get here? It's actually the same situation, so we can apply L'Hopital's rule. But then I'm not going to show the work here because it's actually the same process, right? So, well, actually, all I need to do is to copy this whole expression right here. So what are we getting here? And we can actually look at this expression because we already took the derivative. So if we plug into 2 pi here, we are going to get 0 at the top. But then what do we get at the bottom? We are still, it's, you know that 2 pi and 0 are coterminal, so you're going to get the same stuff. And so the answer, right, for both of them turns out to be what? Just 0. And so that means we know that we will have a horizontal tangent at t equals 0 and t equals 2 pi, which is actually just the same point that we have. Okay, so now how do we actually write down the answer? We can actually start writing down the answer already. And so basically we are just going to say that the tangent, right? The tangent is horizontal. The tangent is horizontal. The tangent is horizontal when we have what? When we at the locations. At the locations, let me see. So we need to have what? We need to have those points, those t values. So we are going to get what? We're going to get x of 2 pi over 3, and then y of 2 pi over 3. So that's one point. And then the other point is going to be 4 pi over 3, right? So you get x of 4 pi over 3, y of 4 pi over 3. And then there should be more, right? There was also the 0. So that's when x of 0 and y of 0. In fact, you're actually just going to get the same point when you are playing the 2 pi. So I'm not going to list that here. And yeah, so what happens is that I need more space. So I'm going to cut out this L'Hopital step right here. Okay, so that I can free up more space right here. Yeah, this problem has a lot of information. Okay, the other one. Yeah, did I get all the points? Yes, I did, right? So we are going. So we have 3 points, and then we also say that the tangent is vertical. Tangent is going to be vertical at what locations right here? We are going to have to plug in. What do we need to plug in right here? We need to plug in. There was the pi, right? There was the pi. There was the pi over 3. There was the 5 pi over 3. So we have those locations. So that's when x is when you plug in pi over 3 into the x and pi over 3 into the y to get the xy values, and then also when you have x of 5 pi over 3 and then y of 5 pi over 3. I'm not going to spend the time showing the calculation here. All you need to do is to plug in the pi over 3 into the t for both x and y, and then you are going to get the xy values for those points. And then the last point would actually be plugging the pi. Okay, and then we put the period at those. Yeah. So that's how we solve this problem. Yes, it's a lot of work. If we're drawing this curve, we are plotting this curve out, right? We're plotting a lot of points and then draw out the curve. We are actually going to get a cardioid. And of course, the polar equation for this cardioid will be a lot simpler, but then if we're using the parametric equations to graph this, to represent this curve, then it will look like this. And then this is a cardioid. And then so if we are to graph out the cardioid, you can actually see that there are 3 points that we have the tangent to be horizontal, and then also that we have 3 points that when the tangent is vertical. Okay. And then so yeah, thank you for watching this video. If you like my video, please subscribe to my channel and then give me some support. And then leave me a comment, give me a like, and then check out my other videos as well. Thank you for watching.